force applications. So the question, it's hard to see right here. What force is needed to keep this rock from rolling down the hill? Okay, so consider a 400-pound rock right here, okay, on the hill with a 30-degree incline. Okay, if F represents the gravity, basically, and V is the incline, then it should say W sub 1. That's a copy paste issue. Is the projection of F onto V? And again, that should be subscripted. The magnitude of W1 subscripted is the force required to keep the rock from going down the hill. So in this first example, I kind of stepped out everything for you. So these are the steps we're going to take when we do the rest of the problems, okay? So F represents the force exerted by the rock due to gravity. So we're starting there. So write F as a vector. Well, gravity is trying to make that rock go down, so that is a vertical component, not a horizontal. So there's nothing going horizontally, but it's trying to make this 400-pound rock go down, okay? Step number 2 says write a unit vector V in the direction of the hill. Well, the direction is 30 degrees. So to write that, and it says unit vector, so think 1 is the length, okay? Kind of like unit circle. So we have 1 cosine goes first of 30 degrees and 1 sine of 30 degrees. Now, using your unit circle, you can also look up tables online. Maybe that's something I need to put up there. Cosine of 30 is a square root of 3 over 2, and sine is 1/2 at 30 degrees, okay? So that's step 1. And then it says in step 3, find W1 in the projection of F onto V, okay? So important things right here. We're dealing with the unit vector, okay? So the magnitude of this would be 1, and 1 is squared, and that is because V is a unit vector. Okay, so we always default to 1 there. Okay, so to find this, we're going to use all this information. Okay, so we're going to take, and I'm going to do this with this still plugging on the bottom, but we don't need it, just to keep in mind. Okay, so moving on, we're going to take 0 times 3/2, and I'm going to write this out so you can have it, plus negative 400 times 1/2, a lot of parentheses. The vector on the bottom is 1, so it's not needed, and then we'd times by vector V. Okay, and I'm just going to write it that way for now. Okay, because it's saying what force is needed. We're not actually trying to find the vector, we're just trying to find out what the force is needed to make this happen. So it makes life pretty easy. So we have 0, and that'd be negative 200. So we have negative 200 V. So it says find the magnitude of W1. Well, if you wanted to find the magnitude, it's just going to be this. And that's because if you did 0 squared is 0, 200 squared is whatever, but then you're going to square root it, so it just goes away. So it's 200 pounds. Okay? So that's the first example. We're going to go ahead and move on to the next one. And right here, we're not actually just going to leave that V there every time. Okay, so life's a little bit easier. Okay? So you can see that you can also use similar triangles in trigonometry to do this, but this is just the route we're going to take. Okay, so a 150-pound cart sits on a ramp with an incline of 60 degrees. What force is required to keep the cart from rolling down the ramp? So step 1, we're going to make the force, and that deals with gravity. So it's 0 and negative 150. Second step, we're going to write the vector V. Since it has a 60-degree incline, it's going to be 1 cosine of 60 degrees and 1 sine of 60 degrees. Okay, cosine of 60 degrees is 1/2, and sine is the square root of 3 over 2. That's step 2. Step 3, we're going to find this projection vector without actually putting the V at the end. Okay, because it's a unit vector, you don't need the denominator. So the denominator is going to equal 1. So I'm not going to put it anymore. I just showed it on that first example. So we're going to take 0 times 1/2, which is just 0, plus negative 150 times the square root of 3 over 2 times vector v. Okay, so if you take the square root of 150 times 3 square root of 2, this would cancel and give you 75. So you get negative 75 square root of 3v. Okay, and the reason there's anything with this is all like a vertical situation is because of that gravity. Okay, so then the question is what are we actually trying to find? Well, what's the force needed? So to do that, we have to do the magnitude. Okay, so we have 75 square root of 3. To find that, you're basically just going to take this and square it. Okay, where's my calculator? Lost my calculator. Okay, because you're trying to find the magnitude. Well, that's the only thing you have to take care of. So, sorry. So like, I'm trying to put this in the calculator. I'm not really helping you. The magnitude says you're going to take that value and you're going to square it and then you're going to square root it. So technically you have like, because it'd make it positive. Well, these two are going to cancel out. So it'd just be 75 square root of 3. But let's get an actual number on that. So 75 times the square root of 3 is 129.9 pounds. Okay, so that is it for force. We're going to move on to work, and that will be the last of the examples we're going to do. All right, so see you in the next video.